Today we start with a discussion on inequalities. And if you thought that equations were hard, well, let's jump in. Let's start a discussion on inequalities with how we graph them on the number line. So let's say we have a number line. Here is 0 and 1, -1, then 2, and so on till infinity, and so on till minus infinity. Now, if I were to represent, say, x is less than -1 on this number line, how will I do that? Okay, so -1 is over here. X is less than -1 means this particular region. So all values lying in this region will satisfy this inequality. -1, since we want x to be less than -1 is not included over here. Let's say if we had to represent x is greater than equal to 2, what will we do then? Then this particular region, including the point of 2, would be satisfying our inequality over here. So let's say if I say x is equal to 4, then does it satisfy this inequality? Yes, it does, because it lies over here in the region which satisfies the inequality. If I were given, let's say x is equal to 1.5, then does it satisfy this inequality? No, it doesn't, because it lies over here, which is not in this region. So it is simple enough to see when we have these simple inequalities where x is greater than or less than a particular value. But what happens when we have these complex inequalities where there are two of them joined with an or an and? What does this mean? This means that the value of x has to satisfy at least one of these two constraints. So it should satisfy this, or it should satisfy this. And means that it should satisfy both. It should be greater than equal to -2, and it should be less than equal to 4 as well. Let's see how we represent them on the number line. So let's put it over here. Let's say we have 0 over here, we have 3 here, we have 6 here, and on till infinity here. And here we have the negative values and so on. So x is less than 3 means this particular region, not including 3, and x is greater than equal to 6 means this particular region, including 6 as well. Now, the values that work for this inequality are those which satisfy either one of these two regions. So a value of x can lie either in this region or in this region, and it will satisfy this particular inequality. So let's say if I say x is equal to -1, then does it work? It does. Why? Because x is less than 3, it satisfies this constraint, and that is enough. As long as it satisfies one of the constraints, that's enough. Let's say if I say x is equal to 4, does it satisfy? No, it doesn't, because it lies over here. This region is not covered by the inequality. Neither is x less than 3, nor is it greater than 6. So this does not work, right? Okay, let's look at the case of and. Again, let's graph this inequality. Let's say here we have -2, here we have 0, here we have 4, here is infinity, and here is minus infinity. So x is greater than equal to -2. So basically this particular region up to infinity, all of this is acceptable, including the point -2. And x is less than equal to 4. So less than equal to 4 means this particular region, including the point 4. Now, note that we have an and over here, which means that the values of x should satisfy both these. It is the overlapping region which will give us the solution. The region between -2 to 4 is the only acceptable region because it works for both the inequalities. So let's say if I say x is equal to 3, does it satisfy these conditions? Yes, it does, because x is less than equal to -2 because it is greater than equal to -2 because it is greater than -2. as well as, and x is less than equal to 4 also, because x is less than 4. So this region from -2 to 4 inclusive, this is the region for which this inequality works, right? Now, if I have x is, let's say, 6, then what happens? If x is equal to 6, then it certainly is greater than -2. So this condition is satisfied. But what about this condition? Is x less than 4? It is not. But we need it to satisfy both the conditions. And since that doesn't happen, x equal to 6 is not a solution over here. It does not work for this set of conditions. Yeah. So graphing the inequality on the number line can help us see what exactly the solution set is for us. Okay, so we have quite a few examples of this in our book, so just go through that. Let's look at operations with constants. Now, we know how the operations are carried out in case of an equality, in case of an equation, right? So, for example, if I have x squared plus 2x equal to 5x plus 6 or something like that, some equation that we have, we say that we can easily add a constant. Let's say we can say 1 plus over here. If we are performing this operation on both sides of the equation, so we can add 1 over here without changing anything. The equation doesn't change. Or let's say we can subtract x squared plus 2x minus 5 is equal to 5x plus 6 minus 5. We can subtract both sides of the equation with the same number, no issues. Then we can multiply both sides by the same number as well. Let's say we multiply by 2, or we multiply by 2 by 3, or whatever, right? Or we can divide both sides by the same number as well, as long as we are not dividing by 0, because division by 0 is not allowed, right? So we know that in case of an equation, we can add a number on both sides, subtract a number from both sides, multiply both sides by a number, or divide both sides by a number without changing anything. The equation stays as it is. Now, how does it work out in case of an inequality? When we have an inequality such as, let's say, x minus 5 is less than 4 or something like that. Now, can I add a number on both the sides? Yes, I can. No worries. Let's say I add 5 on both the sides. The inequality stays as it is, no problem. Can I subtract a number from both the sides? Yes, I can. Let's say I subtract both the sides by -6, right? And I put -6 over here. Again, no problem. We've subtracted 6 from both the sides. It works. Now, what about multiplication? If I have an inequality, let's say x minus 5 is less than 2x. Now, can I multiply both the sides or divide both the sides of the inequality by the same number? Well, I can do that as long as it's a positive number. So I can multiply both sides by 2, nothing changes. Or I can divide both sides by 5, nothing changes. Everything stays the same as long as the number is a positive number. Again, remember, division by 0 is not allowed. Now, what happens if the number is a negative number? Say we have x minus 5 is less than 2x. What if I multiply both sides by, let's say, -1? Then what happens? Then the inequality sign flips and becomes, since this was a less than sign, it becomes a greater than sign. When I multiply both sides by a negative number, this becomes 5 minus x. Because -1 multiplied by x gives you -x, and -1 by -5 gives you 5. And this becomes -2x. So the inequality sign flips when we multiply by a negative number. Again, it flips when we divide by a negative number. Look, division is nothing but a kind of multiplication only, right? So if I say that I am multiplying an inequality by 1 by 3, basically I'm dividing by 3. So it's the same thing only. So in case we are multiplying or dividing an inequality by a positive number, then nothing changes. The sign stays as it is. But in case we are multiplying or dividing by a negative number, then the sign flips. So if it is a greater than sign, it becomes a less than sign. And if it is a less than sign, it becomes a greater than sign. Remember this. So adding or subtracting a constant is just the way it happens in an equation. But in case you're multiplying or dividing by a constant, by a negative number, then you have to ensure that the inequality sign flips.